So, we heard that you guys are having difficulties understanding some of the lessons in pre-calculus. So we, the Mathematics Club organization, prepared this video for you guys to discuss the following. First, what is the unit circle? Second, what is the central angle? And lastly, third, the circular function. We hope that this video may help you understand the lesson. So without further ado, let's get into it. First, what is the unit circle? The unit circle is a circle with a radius of 1. Being so simple, it is a great way to learn and talk about lengths and angles. The center is put on a graph where the x and y axis cross. Now, what is the equation for the unit circle? We all know that the standard form of the equation of a circle with center at the origin is x squared plus y squared is equals to r squared. So therefore, the equation of the unit circle is x squared plus y squared is equals to 1. Because the radius is 1, we can directly measure sine, cosine, and tangent. Additional knowledge. Did you know that in topology, it is often denoted as S1 because it is a one-dimensional unit and sphere?
Hi, I am Angel Barden and now let's talk about central angle. First, what is central angle? Central angle is an angle whose apex vertex is the center of a circle and whose leg sides are radii intersecting the circle in two distinct points, A and B. Central angles are subtended by an arc between those points, and the arc length is the central angle of a circle of radius and measured in radians. We can also call it as the arc angular distance. A central angle is an angle with endpoints and located on a circle's circumference, and vertex located at the circle's center points. Let us know what is the importance of central angle. As a per central angle definition in geometry, it is the angle subtended by the arc of a circle at the center of a circle. The two radii make the arms of the angle. Central angle helps to know the proportion of the curve with respect to the circle. The properties of the central angle. The apex vertex of the central angle is the circle center, while the leg sides are radii intersecting the circle in two unique positions, A and B. An arc between the two locations subtends the central angles, and the arc length is the central angle of a circle of radius 1 measured.
Thank you, Angelo Barde, for presenting the central angle. I am Anita Talatayo, and let me discuss to you the circular function. So what is circular function? Circular functions are defined such that their domains are sets of numbers that correspond to the measures in radian units of the angles of analogous trigonometric functions. The ranges of these circular functions, like their analogous trigonometric functions, are sets of real numbers. These functions are called circular functions because radian measures of angles are determined by the lengths of arcs in circles. In particular, trigonometric functions defined using the unit circle lead directly to this circular function. Did you know that there are 6 functions of an angle commonly used in trigonometry? Their names and abbreviations are sine or sin, cosine or cos, tangent or tan, cotangent or cot, secant or sec, and cosecant or CSC. Suppose theta is an angle plotted in standard position and P is 2x and y is the point on the terminal side of theta which lies on the unit circle. The side of theta denoted sin theta is defined by sin theta equal y. The cosine of theta denoted cos theta is defined by cos theta equal x. The cosecant of theta denoted CSC theta is defined by CSC theta equal 1 over y. The secant of theta denoted sec theta is defined by sec theta equal y 1 over x. The tangent of theta denoted tan theta is defined by tan theta equal y over x. The cotangent of theta denoted cot theta is defined by cot theta equal x over y. And now, let's move on to the example of the circular function. Direction. Use the unit circle to find the exact value of each circular function. Find the exact values of sin 3 pi over 2, cos 3 pi over 2, and tan 3 pi over 2. The angle of 3 pi over 2 intersects the circle at point 0 and negative 1. Since sin is s equal y, cos s is equal to x, and tan s is equal to y over x. Therefore, the exact value of sin 3 pi over 2 is equal to negative 1, cos 3 pi over 2 is equal to 0, and tan 3 pi over 2 is undefined. That's all, and now here is Jonas Ramos to present the size of circular function within the quadrant.
Good day. This video shows how the signs of the circular functions depend on quadrant containing the terminal side of angle in standard position. It is important to know the sign of each circular function in each quadrant. So in quadrant 1, all circular functions are positive. In quadrant 2, only sine and cosecant functions are positive. In quadrant 3, only tangent and cotangent functions are positive, and in quadrant 4, only cosine and secant functions are positive. So before we proceed to an example, let's first know the reference angle in each quadrant. Quadrant 1, reference angle is equal to angle, and in quadrant 2, reference angle is equal to 180 degrees minus the angle. In quadrant 3, reference angle is equals to angle minus 180 degrees, and in quadrant 4, reference angle is equals to 360 minus the angle. Use a reference angle to find the exact value of circular function. For example, cosine 225 degrees. Solution. First step is to determine the quadrant of terminal side of angle in standard position. The angle is equal to 225 degrees is in quadrant 3. Step 2 is to find the measure of the reference angle. Since it is in quadrant 3, reference angle is equals to angle minus 180 degrees. Substitute 225 degrees equals 180 degrees is equal to 45 degrees. Next step is the quadrant 1 of the unit circle to find the cosine of the reference angle. Cosine 45 degrees is equal to square root of 2 over 2. Step 4 is to adjust the sign of the circular function based upon the quadrant of the terminal side. Since it is in quadrant 3, cosine angle is negative. So the final answer is the cosine 225 degrees is equal to negative square root of 2 over 2. So this is the Mathematics Club organization. We hope that this video helps you to understand some of the pre-calculus lesson. Thank you for listening.